Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to another episode of the Reliability Matters podcast. I'm so glad you're with me today. This is episode number 94. Now, what does that mean? That means we are 6 episodes away from the magic number 100. I never thought we would get to 100. I never thought we'd get past 10, to be candid. I started this podcast about 2.5, 3 years ago, kind of on a lark. I just thought, well, we haven't done podcasts before. We've done many other types of communication mediums, but we've never really concentrated on podcasts. Let's give it a shot and see what it's all about. And I thought we'd do 5 or 10 episodes, and then we'd move on to whatever the next popular medium would be. Well, it turns out this is a popular medium, and this is episode, as I said, number 94, and we're 6 episodes away from number 100. So we're going to celebrate episode 100 a little bit differently than as an episode than our normal episodes, and that is number 100 will be live. Normally, I pre-record these and fix all the mistakes that I make, so it comes out a little bit more seamless. But we're going to go live on July 26th. That will be our 100th episode. So it'll be live on Facebook, on YouTube, and on LinkedIn. So I'll be sending out information on how you can view that 100th episode live on July 26th in the upcoming days and weeks. I'll be sending that information out. In the meantime, let's get on with this episode. Dr. Ron Lasky is my guest today. Dr. Ron Lasky is a Senior Technologist at Indium Corporation, as well as a Professor of Engineering at Dartmouth College, where I have twice had the privilege of speaking to Dartmouth students on the Dartmouth campus. If you're like some people who view the next generation of young adults skeptically and perhaps pessimistically, I can assure you that your view would quickly change after spending any amount of time with his students. Dr. Lasky has more than 30 years of experience in electronics and optoelectronics packaging at IBM, Universal Instruments, and Cookson Electronics. Additionally, he served as an adjunct professor at several colleges, teaching more than 20 different courses on topics ranging from electronics packaging, material science, physics, mechanical engineering, and science, and religion. Dr. Lasky holds numerous patent disclosures and is the developer of several SMT processing software products relating to cost estimating, line balancing, and process optimization, all subjects of paramount importance in today's hyper-competitive environment. He is the co-creator of engineering certification exams that set standards for the electronic assembly industry worldwide. Dr. Lasky was awarded the Surface Mount Technology Association's Technical Distinction Award in 2021 for his, quote, significant and continuing technical contributions to the SMTA. He was also awarded the SMTA's Founders Award in 2003. Dr. Lasky holds 4 degrees, including a PhD from Cornell University in Materials Science, and is a licensed professional engineer. He has authored 6 books and contributed to 9 more on science, electronics, and optoelectronics, and has authored numerous technical papers. And today, I'm going to be talking with Ron about some of those books. So without any further ado, let me bring in Ron Lasky. Hi, Ron. That was a long intro, but your work experience and your education and your accomplishments, they just kind of produce a long intro. So
thank you.
We almost need a show just to describe you. Man of many talents. Well, welcome back to Reliability Matters. This is your second appearance, I believe, on this show. Yep. It's good to see you again. Perhaps before we get started, this is, I feel a little bit like this is going to be like the Oprah Book of the Month Club or something, suggested reading. But before we get into that, let's remind our audience how you and I got to know each other. We've known of each other for years because both of us have been roaming around this industry for several decades, I believe. But we got to know each other a little bit better in 2019 when both of us were in Hawaii for the Pan-Pacific Microelectronics Symposium, PanPac. I was second in line, a very long line to eat breakfast, to be seated. And I looked over my shoulder behind me and I saw you about 10, 15 people back, probably a good 20-minute wait for you to get up to the front of the line. So I'm like, hey, Ron, come, if you're by yourself, just come join me. I'm by myself and get a table for two instead of a table for one. And then we got to talk and I shared a little bit of my story, you yours. Next thing you know, you invited me out to Dartmouth to speak to your students, which was absolutely awesome. It's an awesome campus, beautiful campus. And the students were inspiring me, probably way more than I inspired them. And now I've had the privilege of doing that twice. It's an awesome experience. As I said in the intro, any negative view or pessimistic view one older generation typically has for the younger generation is certainly put to rest when we get to sit down and talk with these young adults. They are our future, and I envy your job as being able to work with them and help mold their professional life and their education the way you do. So,
thank you.
Let's get into some books, shall we? There are a number of books that you've had your hand on, either you've written or you've co-written or you've inspired. And let's start with this one, the Handbook of Electronic Assembly. Now, this book was a predecessor to another activity you were involved in. Why don't you explain to me and my audience what brought you to co-write this particular book?
Well, Phil Zarro and Jim Hall and I developed the SMTA certification program. And one of the things that became clear is there are many books written about SMT assembly, but there really isn't a handbook that tells somebody relatively new to the industry the basics of how to do electronic assembly. How to set up a sprint printer, how to design a stencil, how does wave soldering work. And so Jim Hall and I mostly took the lead in writing it, and we used the material from the SMTA certification course to develop a book that you can actually read instead of just looking at the slides and pretty much on your own learn it. And I've actually used it at Dartmouth for a few self-study courses. I've had some students say, Professor, I need one more course. You have something practical that I could do. So I give them the book and let them read it. And I actually give them an exam at the end. And it's, really rewarding to see someone that doesn't know anything about electronic assembly probably be ready to go out into the world and be as good as anybody.
And the tell me what led to the actual certification course. We're going to talk about the book a little bit more, but the book was, obviously kind of an afterthought, like it was an accident, but it was, once you developed the course, you decided to memorialize some of that information in the book. What was the inspiration for the course? SMTA, up to that point, had not been known as a trade organization that provided certifications. SMTA, up to that point, did a lot of other things, education-wise, symposiums and technical conferences and educational material and papers and things like that. What made you and your colleagues come up with the pitch to SMTA to create a course?
And I guess this is probably a story I haven't told many people. So before 9/11, I was working at Cookson Electronics, and we had thought of developing something like this, and we're sort of beginning to, develop it. And then 9/11 happened, and the part of Cookson Electronics that I was in just about went out of business. So I got laid off right after 9/11, and ended up. That's when I became a professor at Dartmouth and started working with the wonderful folks at Indium Corporation. And I knew Phil Zarro pretty well. I'm not sure I had met Jim Hall yet. So I called him up and I said, we had this idea at Cookson Electronics. We didn't really have time when I was there, to bring it to fruition. And so why don't we get together? And I thought the three of us could develop the course. So we got that idea, and then we met. I think you remember Joanne Stromberg. She used to be and so we met with Joanne, see if she thought it was a good idea. So then we met with the board of SMTA, and I was pretty impressed how quickly we developed. We developed it in less than a year, and we had the inauguration of the first workshops in SMTAI in 2002. So it'll be 20 years in this fall. And one of the reasons we thought about it is the combination of Phil and I and Jim have probably been in more than 100 factories worldwide, and we just find that most folks that are professionals that get a job and work at a company, there isn't any source they can go to learn how to really do the basics. So the certification process actually starts with a day and a half of extremely intense teaching, assuming that the people coming there have some reasonable amount of experience. We don't recommend anybody take it unless they've worked as a SMT assembly professional for 6 months.
Yeah, that's what I was going to ask you. What's the kind of recommended entry requirement? It's obviously a little bit more than a 101 course. Is it as high as a 201 or higher, or is it intermediate?
We suggest that it would be intended for someone that has at least a 2-year degree, technical degree, like an associate's degree or equivalent, and something like at least 6 months of practical experience. Realistically, what we usually find is a number of folks that come really need a lot of coaching during the teaching part, and especially with the mathematics. It's not super difficult mathematics, but there's some algebra and sort of like calculating costs and things like that of assembling something. And that's usually where people struggle a bit. But I should know this exactly, but I'm going to guesstimate that more than 90% of people pass it. So it's got a pretty good success rate. And I'd say with people that have a bachelor's degree, like in mechanical engineering, I'd say that it's pretty unusual that someone with that background will not pass.
Do you see a trend in the students that take this course in things they come into the course with that are just wrong and need to be reprogrammed? Does that degree of reprogramming change over the years, or is there a consistent fallacy or myth or that you have to bust and reprogram?
Well, usually we, and I know it's going to sound a little negative, but we assume that people really don't have much background, because we find that we'll be in a class and we'll be talking about SAC solder, and we find out that out of 20 people, 3 or 4 don't really know that SAC stands for tin, silver, copper. And so we pretty much cover everything, but our anticipation is that something like that most people would know. And sadly, it's a little surprising sometimes. People that even work quite a while in the industry, I guess, just aren't curious. And that's a particular one. If I say SAC 305, they don't know that that's 3% silver, 0.5% copper, and the balance tin.
Right. It's SAC 305. That's all it is. It's just SAC 305. Right.
Yeah.
Well, I remember when I first got into this industry in 1985, I was just raw. I had never worked in the electronics industry before. I came from a completely different industry. So one of the, back in the days when we actually had paper magazines, to read before the internet, I remember one of the most valuable assets printed in the back of this magazine. Probably they had an extra ad page they didn't sell, so they threw this in there. Was just a glossary of acronyms for our industry, because we are an acronym-rich industry. SMTA, IPC. Everything is an acronym. And
here's one you may get a kick out of. I've even seen people that are senior professionals. They don't know the technical difference, because there is one between a PWB and a PCB.
Printed wiring board, printed circuit board. Yeah.
Printed circuit board. The printed wiring board is before you assemble the circuits on it.
Yes.
So after it's assembled, it's a printed circuit board.
Right. Printed circuit assembly versus printed circuit board, before or after reflow, basically. I find those very helpful. And like so many people, I suffered a little bit of imposter syndrome when I first came into this industry. I felt like, no one realizes I snuck in the back door and I don't know anything, right? it was very helpful to learn the acronyms, because you start
Sure.
throwing around some acronyms and all of a sudden people go, oh yeah, that person's one of us.
Yeah,
So
and I would say to anybody new in the industry that wants to get maybe a year of experience before they take the program, just be curious. Pick up that jar of solder and ask yourself, well, what does SAC stand for, and what does the 305 stand for? And in your daily job, always be curious, asking questions,
yeah.
and you'll be well prepared in a year of experience if you do that.
Yeah, I think what helped me is I'm of a curious mind anyway. I used to get into
Yeah,
trouble when I was when I was
sure.
a child, because I used to take apart my parents' clock radios and television sets and
Sure.
anything electronic, transistor radios, to figure out how they worked, or at least to see what was behind the cover. The reason I got in trouble is I didn't have as much interest in putting everything back. So there would be this
Yeah, sure.
pieces
Yeah,
of,
right.
of stuff everywhere. But
Mhm.
I think Steve Jobs actually gave a commencement address where I think he said something to the equivalent of, stay curious, always be curious,
Yes,
always
right.
always
Absolutely.
learn.
Sure.
And modern internet technology has made it so much easier to learn. No, we might
Sure.
not be learning
Absolutely.
things accurately because the internet is
Mhm.
filled with as much misinformation as valid information, but still we
Sure.
have the ability to reach out and learn a whole lot easier than my parents' old annual subscriptions to the Encyclopedia Britannica, right? That was
Right. That's right.
quite
Absolutely.
limited
Yeah.
learning.
Sure.
So the book, which came out of the Handbook of Electronic Assembly, a guide to the SMTA certification, and that book is available, I should say, through the SMTA bookstore.
Mhm.
It's 200. No, that's another book. It's a beefy book, as I
Yeah.
recall. That came out of the certification course. Do you recommend that people read that book before taking the
Oh, that
certification
that
course,
would
or is it
that
a
would be that would be so helpful if you could read that and only retain even 60% of it, especially in areas where you don't know things. It would make it so much easier to take the test. Um, and as an example, maybe you're really into SMT assembly, but you've never even seen a wave solder machine. Well, that's part of the course, and we feel that's important. So that there's enough detail that uh, you should be able to do everything on the exam if you all of the know all the material of the book. But I think would be really helpful.
right? Okay, very good. Let's go on to another book, and that would be this one right here, the
Sure.
Printed Circuit Assembler's Guide to Solder Defects. Now, you and Christopher Nash wrote that book. Christopher's with Indium as well. Is that
Yeah.
correct?
Sure.
All right.
Yep.
What's that book? I love books about, and I love trainings about what goes wrong. I love
Sure.
to do,
Sure.
whenever I interview a guest, a subject matter expert in a specific subject, I always ask, what do your customers do wrong? Because I find
Right.
teaching is a lot more effective on not necessarily how to do it right, but here is what not to do, right?
Sure. Sure.
I wrote a book on my journey as an entrepreneur, and basically the book is filled with everything I did wrong. Not do what I
Yeah.
do what I did, but don't do what I did, right? Because I think negative reinforcement sometimes is more effective than positive reinforcement, at least in this context.
To support you, I've of course seen your talk when you came to Dartmouth. It is so helpful to the students to see the experience you went through and exactly what you're saying. A lot you learn a lot from the things you do wrong. I think somebody even said you don't learn anything from the things you do right. Right.
Well, yeah. I mean, if I were to be interviewing, two people, and for a key position in my company, and one has had a trail of successes, never had a failure, and the other has had a mixture of failures and successes, I would always go for the failure and success
Yeah.
person,
Yeah.
because
Agree.
I don't know if you can go sit at a roulette table in Vegas or Atlantic City and you could win 20 hands in a row. Does that mean you're a good gambler, or does that mean that luck was on your side?
Yeah.
Probably the
Right.
latter. So I don't know if a person's never experienced failure. I don't know if they've just been lucky or if they're truly talented. And I
Sure.
would rather go with someone that's fallen down a few times and has learned,
Mhm.
I'll never do that again. They'll fall other times, but they'll never repeat that mistake, and know
Sure.
that the mistakes are out of them before they come on my team. That would be good. So let's talk about the book. What was the inspiration for this book?
Well, one of the things that myself and my colleagues at Indium Corporation, like Chris Nash, uh, there are a lot of defects out there, and companies like Indium Corporation that make materials for electronics assembly like solder paste really have a lot of experience in solving them, because in some respects, almost every day they get customers calling, help us with this problem, help us with that problem. So we felt, Chris and I and some of the other folks at Indium Corporation, that we had a pretty good amount of knowledge in this, and you can't just go to one place and learn how to solve the most common defects in electronic assembly. So we said, well, why don't we put together a booklet? And it is a free booklet, by the way. As a matter of fact, the only of the three books we're going to talk about, my book, the only one that is you have to pay for is the SMT certification, and I don't think it's super expensive, like $50. So Chris and I did this over a period during the COVID time, and I think it would be very helpful, again, free, even if you don't have these problems yet, to pick the book up. I think it's about 60 pages, and know what causes voiding, or what causes head and pillow defects. So if they ever do happen to you, you've got kind of a leg up. Or maybe if you're developing a new process, to know beforehand the things that you can do that will minimize any of these defects happening.
And for my viewers and listeners, if you want to get a hold of that book, it's available at Indium, and I will put a link to the part of the Indium website where that book can be found in our show notes. So if you're watching this on YouTube, just look down where it says "Show More," and you'll see a link to that. And if you're on the audio only version, like on Apple Podcasts or Google Podcasts or Spotify or Amazon Music, wherever you're listening, look at the show notes, and that'll be there as well. There was a time on the show when I thought we would never stop talking about voiding. That was just the conventional wisdom defect of the year, for many years. And I had two sets of experts. Two experts fell into one of two categories: either those that said voiding is overrated, it's not as big a problem as people think, you only need a small percentage of contact in most cases anyway, and we're just it's a red herring. And then those that were, the opposite of that, like, no, we really need to go toward 100%, contact, and, as close to 0% voiding as possible. So I've had both opinions on this show, and probably both are valid depending upon the application, right?
Yeah, sure.
It's not just, obviously, it's not just electrical contact, it's heat dissipation and all that stuff, which could be very important. What is voiding still the poster child of solder defects, or has that morphed over the years we've been soldering?
I think it is. Indium Corporation did a non-scientific survey. It's got to be at least 10 years ago, and concluded that was the number one defect concern. And I think that's still true, because we haven't really completely got bulletproof techniques to completely get rid of it. I think we can dramatically minimize it. I guess I should correct that. I think if you're willing to use a vacuum reflow oven, you can get it down to probably a percent or two. But in the book, we also discuss, and I've written some papers on it. I think I presented one at SMT PanPack this year, SMTA PanPack, where even without a vacuum oven, you can consistently get down to certainly less than 20%. And I think most people agree, if you're something like less than 20% of the area voiding in the thermal pad of a bottom terminated component, you're in pretty good shape.
Now, one of your many occupations is, you're a senior technologist at Indium. Indium is a materials supplier, solder paste and metals, things like that, and fluxes, among other things. How much of solder defects falls on the material selection process or lack thereof, and how much solder defect issues fall on process?
Yeah, I think it's a kind of a tough question to answer. The thing I can say is that companies like Indium Corporation have studied a lot of these defects and have made their products such that they minimize them. In other words, if you're having the head and pillow defect, there are things in your process that you can do to minimize that. Although Indium Corporation and to be fair, they're worthy competitors, some of them have developed solder pastes that minimize this effect without having to change the process. They're just more robust to minimizing the head and pillow defect. But assembly is an optimization process, and you can't make everything better by a change. So you might minimize the head and pillow defect and have other concerns. So typically what we do is we try to work with our customers and tell them what we think are the better of our materials to minimize a certain defect, but also work on the process, because there are certainly things in the process that you can do that will help to minimize the different defects. And just like voiding, we have solder pastes that really perform very well in voiding, but we'll also tell you the 4 or 5 or 6 things you can do in your process to minimize it, like the right type of stencil aperture to have, and the right type of reflow process to have to minimize voiding.
So it sounds like the most correct answer to the original question, is it materials or process, is yes. It's both,
yeah.
right? You have to have the right materials
this
using the right process.
This is one of the things I was going to encourage everybody. I mean, I'd be thrilled to have you get the defects booklet and read it and everything. But one of the things to remember, if you do start having some sort of defects, the people that work at your materials and equipment suppliers, they deal with these defects a lot. So one of the first things I would do is call up my material supplier or my equipment supplier. And I'm sure you have that in your world too, where you can often help the people a lot and save them an awful lot of time. Because when you look at some of the technical people at companies like Indium Corporation or your company, or they're often dealing with defects from their customers almost every day and helping their customers. So they have an awful lot of knowledge that you wouldn't necessarily expect to find in a person that works in an assembly company, because they haven't seen, all the different flavors of defects, because they're only one company.
Yeah, that makes sense. The big buzzword right now that I'm hearing is, low temperature solder, LTS, low temperature solder.
Yes.
Let's talk about low temperature solder. When not necessarily new technology, but when a technology becomes popular, and trendy, like low temperature solder is at the moment, does that come at a cost of other defects? In other words, does low temperature solder have any effect on voiding, positive or negative, or does it have other effects that then have to be mitigated?
Yeah, that's a good question. I'm not sure we know enough yet about low temperature solders, because I don't think they've really been, out there that long. One of the things, especially if it's a bismuth-based solder, is it's really hard to get the kind of reliability you get with a SAC-based solder, especially in drop shock, because and things have been done to make them better. I want to make sure I say that, and in many cases you can get very good results, but you won't get as good drop shock resistance with most of the bismuth-based low temperature solders. That's why some companies, like, and I'm not sure you're aware of this, Indium Corporation has developed a SAC-based solder that you can reflow at temperatures more like a little over 200 C, maybe 210, 220, instead of, most SAC solder you have to take up to about 240 to make sure you melt it. And there's one, and I promised myself I wouldn't make this too much of an advertorial, but Indium has a new solder paste called Durafuse that it's much more close to a SAC-based solder, not a bismuth base, and will reflow at a temperature closer, not exactly as low as bismuth base, but closer.
Does it use the same metals, or is it the same metals in different percentages, or is it a different composition that allows it to reflow at a lower temperature?
It uses a principle that I think some people aren't quite familiar with. One of the ways I explain it is gold melts at a very high temperature. I can't exactly remember it, but it's about 1,000 degrees C. Mm-hmm. But if I drop my wedding ring into a jar of mercury at room temperature, the mercury would dissolve the gold.
Right.
So what the folks at Indium have done is they've mixed a small amount of some other solders in with a SAC solder, and it enables it to melt at a relatively low temperature, but then when it freezes, it has more of the properties of SAC and would only melt at a higher temperature.
Right.
And it's pretty much, I think, a new concept in the industry. And, I think it's pretty exciting.
I realize we're kind of going down a rabbit hole here, but just to finish the thought, the reason I asked that question about a new technology having a knock-on effect of defects we now have to address. One of the concerns I've always had with low-temperature solder, just from a principle standpoint, is we did a study with our friends and colleagues at Foresight Analytical Laboratories in Kokomo, Indiana, where we ran a SAC material and purposely reflowed or set the peak reflow temperature about 5% lower than it should be. And ran a bunch of boards at proper peak reflow temperature, and then boards 2% lower, 4% lower, 5% lower. And when we got down to the 5% lower, we detected sizable increases in contamination, using ion chromatography, localized extraction, ion chromatography, upwards of 600 to 800% increases in contamination under certain components, just as a result of a lower peak reflow temperature. Well, that kind of makes sense if you think about it, because these were no clean fluxes, and no clean relies on activation to burn out the activators and bad actors and make them inert, or as close to inert as possible. And when you don't hit that temperature, then these things are still in business. They're still activators, right? And they're problematic. So one of the questions I've always had, and I don't expect it to be answered on this program, but one of the genesis for my question was, will we end up with low temperature solders that solve one problem, and then we realize that, well, now you got to clean them more vigorously because we're not activating all the bad actors.
Yeah, that's one of the things, and I'm not being specific, but often we make changes for reasons, and we get the good result we want, and then we find that there are unintended consequences. And I think you're saying that, and I think the only way to determine that is do it and run different tests to see how things work out. But that's a really good point, and I think I made it earlier. If you're trying to minimize voiding, it may exacerbate some other failure mechanism. And
right.
It's just impossible to have one set of materials and process equipment and process that eliminate all defects, because some of them are mutually exclusive.
Right.
Like a profile that's really good to minimize voiding, in some cases you can have longer time above liquidus that will exacerbate something like graping, which is a phenomena where you get some oxidation of the solder powder.
Yeah.
And so it's a balancing act.
In our industry, as I've said this on the show before, our industry is notorious, probably be the right adjective, for coming up with new packages that are brilliant. And we can pack QFNs, BGAs were the first example of that brilliant new package where all your connections are at the bottom, and you can pack a lot of technology into a relatively small footprint. But then the industry says, well, how do we solder these? Everything's at the bottom. We can't see it. And kind of the packaging people go, well, that's your problem. And then we have several years at symposiums where we teach our experience, and then someone says, well, how do we inspect them? And then, the X-ray people go, well, we have a solution. But this industry is known to evolutionize, in some cases revolutionize, without an instruction manual. It's up to industry to kind of figure it out.
I was even thinking, in the 90s, the 0402 passive was about the smallest. Then we went to the 0201, then the 01005, and I think we're even smaller than that now in some cases. And the people that invent these don't even think about the fact that they're going to be hard for people to assemble. And of course, they're desired because of density. You can get more into a smaller space. But and whenever the new ones have come out, like I remember when an 0201 came out, the solder paste inspection people that have like the laser scanners that look at the deposit of solder paste, they then had to scramble because they didn't have the optics capable of doing that small of a solder paste deposit. And then the 01005, and you're constantly having to up your game essentially to keep up with some of the things invented by the folks that probably aren't worried too much about how hard it's going to be to assemble as you
right.
it out.
In my technical presentations, I have a slide that I've overused it. I love to use this slide. It shows a mom yelling at her young child, finger pointed, bent over his head, yelling at him. And I said, this is what happens when you don't tell your children you love them enough. They either grow up to be serial killers and sociopaths or bottom terminated component designers. One of the two. And, to get back at society. So we talked earlier about Phil Zarro and Jim Hall, and they're with a company called ITM. I think you have an association with ITM as well. ITM is a consulting company. Now, I define a consulting company. Some people think this is like an insult. It's not actually. I think I define a consultant as someone you hire to tell you what time it is and the first thing the consultant asks you is, "Can I borrow your watch?" And meaning that the answers are there. The consultant's not really just coming up abstractly with an answer. The answers are right there. Just your clients can't see it, right? They don't know where to look.
Very often the case. Absolutely.
Yeah. So how did you get involved in that part of the world, the consulting world? And are you still as deeply involved in it now with all the other activities that you have?
Well, so I mentioned I got laid off from Cookson Electronics right after 9/11. And it was kind of sad because the part of the company I was with, Speedline Electronics, their business was off 85%. That is not from X to 0.85X. It was X to 0.15X. So I decided that I was going to see about consulting just with Indium Corporation. So I had met the president at some of the SMTA conferences. And so I said, I'd like to consult with you folks if you'd be interested. I had been at IBM for quite a long time, so I had an early retirement and I had medical benefits and everything. So I didn't need the benefits. So they said, yeah, why don't we talk about that? So that was 2002, and it's about 20 years ago now. And I've been working with them ever since, probably like one day a week. And that's at first it was a little more than that. But then right around the same time, I had worked with some professors at Dartmouth when my daughter went there, and they knew that I was available, and they asked me to teach a course the same year on optimizing manufacturing processes. And so I started teaching that around the same time I was working in Indium Corporation. Then the students seemed to like that course, so they asked me to teach another course and another course. And before you know it, I'm essentially full-time at Dartmouth. But even if a professor has a research program, the university sort of really encourages you to consult because they want you to be up to speed on what's going on in the real world, so you can, obviously teach your students that. So in some respects, my research program, I don't really have one. I'm what's called an instructional professor at Dartmouth. I'm just responsible to teach courses. But in some respects, my research is done by working with engineers like it at Indium Corporation. They're often doing interesting experiments and presenting the results to customers, and they're just too busy to write a paper. So I'll often get with them, and sometimes they'll just give me a PowerPoint presentation, and I'll turn it into a paper, and I'll learn from them. They'll learn a little bit from me, and then we'll co-author papers at SMTAI and SMTA PanPac. And so I'm going to guesstimate I've written in the 20 years probably 40 papers, maybe more, with folks from Indium Corporation. And there have been times too when I've been asked Phil Zarro and Jim Hall if they'd like to participate. But one of the most rewarding things, and you alluded to this, is often I will recruit a student at Dartmouth, more or less to alleviate a little bit of the writing for me, because they usually write really, really well. And I might give them the PowerPoint presentation and ask them to sort of make a draft, and then I'll work on it and then send it to the engineer at Indium Corporation that did the original work and make the student a co-author. And as you know, you had some on your podcast. Some of the students from Dartmouth actually went to PanPac a couple times, and it's just like super rewarding to help young people like that. And of course, when you go to a college in New England, going to SMTA PanPac in February is a big treat.
Yes.
So,
and yeah. I believe in addition to recruiting students to come to PanPac and deliver papers, I think this year your daughter was there, if memory serves. Is that correct?
Right.
Who was an endocrinologist, and she gave a fascinating keynote about about COVID-19 and other major outbreaks. And she did a great job of speaking to a group of non-medical doctors about very complicated issues. And it was a really good course, by the way. It was a very good keynote, and should be quite proud.
Thank you.
So, getting back to our next book, which was written by Phil Zarro and Jim Hall. Were you part of that writing also?
No. But the reason I wanted to talk about it is Phil and Jim. It's actually a compilation of all of the excuse me, they have a, I guess it's like a podcast called Board Talk.
Yeah, before you
And
go any further, let's let our audience hear just a
okay,
small clip of Board Talk for the maybe one or two, if any, people
that haven't
in
heard
this
of it. Yeah.
audience that have never heard of Phil Zarro or Jim Hall. They have a pretty unique style of providing highly technical information. It is almost a comedian and a straight man, right? That
Yes.
Phil Zarro's a little on the goofy side, and Jim Hall is a little bit more of the straight man role. But together, they make learning technical best practices fun. If you can, if
Yeah.
you
Sure.
can imagine any version of fun in our world, they
Our world.
do
Yeah. Yeah.
make it fun and a little bit goofy and memorable. Well, they have as you suggested, they have it's kind of like a podcast that they do on I think it's circuit technology or circuit
Yep.
technology.
Circuit Tech. Yeah.
Circuit Insight or something. Yeah, and it's called Board Talk. And for those NPR fans who remember Car Talk, two guys from New England talking about how to repair a car and all the problems that go on with your car, they kind of mimic that style. And here's just a small 60-second clip of the intro to the show and the outro to their show.
And welcome to Board Talk. This is Jim Hall and Phil Zarro, the Assembly Brothers, pick and place, or place and pick. And we're here to answer your process questions regarding SMT and the associated realm. And we're coming to you today from our cave up high at Mount Rialto in the White Trash Mountains of New England. And let's see, what's today's question, Jim? What do we got?
Question today comes from ER.
Emergency room. Uh-oh.
You have mentioned about proper exhausting of the reflow oven. Hey, Phil, this is a repeat. This is a listener. Thank you, ER, for listening to us. We have stimulated your thinking.
I didn't know you can listen to this in the emergency room, but that's pretty good. Okay.
At what exhaust pressure normally should the oven be measured at?
Oh. Well, the only thing I could add to that is no matter how you're exhausting your reflow oven,
Don't solder like my brother.
don't solder like my brother.
Don't solder like my brother. That's their trademark goodbye on their show. So they have been doing this Board Talk show for years, and
Years.
it looked like they took many, if not all, of the Q&A that they've dealt with on the show and memorialized it in a book. So,
Yeah.
what's your take on the book?
Well, I would say that I did not do any of the writing of the book, but I think the thing I did do, and I'll be interested to hear it's Phil and Jim, because I'm sure they're going to watch this because I mentioned I was doing this. I think I harassed Phil especially for quite a long time. I said, there is no place in the world where you can get this kind of information. There aren't books that talk about, a question like was asked by that person. I mean, it's not really defects. It's like pretty much how to do things. And you guys have done a couple hundred of these. Why don't you put it into a book with an index so people can pick it up and read it and learn how to, all these different things like, worrying about components falling off on the bottom of a circuit board when you're going through wave soldering or something like that. And or if it's even SMT and you flip it over, will the solder, the liquid solder, will it still hold the component, and sort of rules of thumb for that. And I think it was a couple of years I kind of bugged Phil mainly. So he finally said, I'm going to do it. And so I said, well, let me write the intro to it. So I did write the foreword or something like that to it. But I think it's really an invaluable source of information because, again, there is no book like the SMTA certification book that teaches you how to be a process engineer. This book teaches you the everyday little details that really are really, really important that, there are just so many of them. And I just think it's an invaluable contribution to electronics assembly.
Is there an anecdote from the book that is memorable for you? Is there one story that is funny or insightful that stands out?
I think there's a practical one that I just mentioned. People wrote in, I'm doing double-sided SMT, and I'm going to flip the board over, and I've already put components on the bottom. how can I be sure that the component won't fall out? And they talk about the amount of weight you can have per the area of the pad, and there's a rule of thumb for this, and I don't know where else you could easily find that. And what you find is that both of them, the combined knowledge they have, practical stuff like this, I don't know is equal anywhere else in the industry. It's just, they've just have decades of knowledge and a lot of little details like this that you can't replace. And I have to agree too. Phil is just hilarious. He could be a stand-up comedian, and he is the comic, and Jim is the straight man. It really makes it a lot of fun. I'm sure the whole thing where in this, what we heard where the person's initials were ER, I'd almost guarantee you that wasn't rehearsed. So I think they told me they never rehearsed. Phil is just so quick. He's got things like that. And, it keeps it fun and light. So.
Yeah, I did some producing for them to digitize one of their training courses and make it available. And I had both Phil and Jim virtually, on a recording session where they were recording their bits. And it was just funny to, even though I wasn't physically in their presence, but I could see them and I could hear them. And it was just funny to see, Jim's eye rolling when Phil goes off on his goofy, tangents. Yeah. And obviously they work well together. They probably also drive each other a little bit crazy. It's just it's a yin and a yang, but it doesn't blend, but it coexists and it's successful because our industry, you face it, our industry is filled with exceptionally intelligent people. And, obviously, this as a professor. It's one thing to have the knowledge. It's another thing to open the vault door and let that knowledge get out in a manner that can be received. And, I've talked with a lot of, very bright people through this show and other venues. And sometimes it's really difficult to get that information out. It's there. They can do it, but trying to get it out in a manner that can be digested and understood and received by people that's a gift in itself. And many people that possess the intelligence level don't always possess the other side of that. That's right? So
we all know geniuses that it's just really hard for them to share their knowledge in a way that others can benefit from it.
Sure. They thought Einstein needed to go to a special school. They thought he had some IQ issues. It turned out he was so bright. He was, borderline judged to be just the opposite of that. So it is a fine line between, brilliance and being able to communicate with the world and function in the world. And not everyone has that. Our industry is no exception. Any technologically based industry is no exception. Let's talk about personally my favorite of the books that I kind of reviewed of yours, The Adventures of Patty and the Professor. Well, obviously, it's no secret who the professor is. That's yourself. Tell me about this particular book. First, before we get into what it's about, what was the inspiration of a book like this?
Well, it does require a little explanation. I believe that I am the first blogger in SMT. I started blogging. Indium Corporation's Rick Short asked me to do it, and so I started blogging a couple posts a month. And it was pretty much the kind of thing that, if you've got this problem, do this to solve it. And I did that for 3 or 4 years, and occasionally I could include some personal fun type things. And then around 2000, maybe 8 or 9, I thought this is getting kind of boring. I said, why don't I invent a character, Patty, who is a superstar young gal engineer, and we're going to talk about her having some of the things that I observed in my consulting and helping people with problems. And so I did that. I would have to say, though, the professor isn't really me. I don't know if you can see this. I'll open the first page and I'll show you what a line drawing of the professor. See if this will work. Whoops, I'm going the wrong way.
Oh, other way. There you go. That's coming. Keep going. Keep going. Okay, there's Patty, and there's That looks more like Bob Willis than it does yourself.
So I say you can clearly tell it's not me because he's more handsome. So and I thought it was only going to be 4 posts because I had a story I so wanted to tell because it was so dramatic. And a number of people, when I gave them a copy of the book, I said, read just the first 8 pages. It's 4 posts about something that really happened. And one of my colleagues said, it was really fun to read, but it just, he didn't read where I said it really happened. He said, nobody could be that bad. And so then when I finished that, I thought, well, I got another idea. And then I got another idea. And for the most part, every post is at least 70% based on fact. The other thing that was kind of fun is I made Patty kind of have a life, and we got to know her pretty well. So she was a hopelessly amazing young woman. And I thought, hey, if I want to develop the characters and I want to have characters that are like superstars, don't be angry with me. So she speaks 4 languages, and she just always does the right thing, and her boyfriend is amazing, and we even go through her getting engaged and then her getting married. So the stories would be 30% about Patty's life. She's also a good enough female golfer that she was thinking of being a pro, but she decided that it's kind of risky, so she'd become an engineer instead.
But she's real in the way that people are real, in that she's not too sure of herself. She has some self-doubt. When she was faced with a male counterpart who was, consuming all the oxygen in the room, so to speak, and convinced that he couldn't be wrong, her tendency was to question herself more than anything else and rely on other experts. So you were able to capture kind of a real human personality in Patty.
Yeah, and I tried to make it fun. It was kind of rewarding when somebody sent me an email. There's also a guy she worked with who was called Pete, who's a little older than her, but not as senior in the company. And they would often go out solving problems together. And somebody sent me an email. Could we have more stories about Patty and Pete? I especially like Pete.
That's funny.
And you kind of get a kick out of that.
Yeah. When you run out of technical things to say, you'll just have to write a romantic comedy about them because we all want to know what happens to them. So let's talk about the first, the first 8 pages, the story, which was based on a true story. Even though the names of the innocent or guilty have been changed, and you took some liberties with their life in general, but the technical challenge was the same. So this was a factory where the professor went in and kind of to do an audit, if for lack of a better word. And one of the first things the professor asked one of the I think the production manager or something was, what's your pick and places machines uptime, average uptime? And that person said, not quite off the cuff, but they said, we've done some calculations and we think we're at 95%. And the professor then said, okay, let me do some studies and, I'll get back with you. And more studies were done, and the actual percentage was, remind me what it was. It was something like 10 or 12% or something. 10%. Yeah. So they thought they were at 95% uptime, 5% downtime, and it turned out to be 90% downtime, 10% uptime. That is a huge gap in reality versus expectation. Where did that story come from? Not who, but what was the genesis of that story, and how is it that common for people within a manufacturing environment to really be off that much?
Yeah, so it's absolutely a real story. Obviously, I won't mention the company. It's a long enough time to go. There's no way you could read the story and know who the company was. But what happened is one of the young engineers at the company was in one of my workshops, and they had 2 assembly lines, and they were fortunate they had a captured business. They were assembling for the parent, and so their business was so brisk. They had 2 assembly lines, and they just couldn't manufacture enough. So the boss said, "Well, why don't we build another assembly line?" So the young engineer said, "Well, why don't we invite," I think most people call me Dr. Ron. "Why don't we invite Dr. Ron to come, and maybe he can help us with our productivity, and we won't have to build another line." So I came, and I asked a few questions, as you alluded to. I first asked him, what do you think your uptime is, which is essentially the amount of time that the line is running as a fraction of all available time. And, they hemmed and hawed a little bit. They said, well, we think about 95%. So I asked him a few metrics, like how many boards to produce a month, this and that. So I had to put together a little Excel spreadsheet. And I said, well, from what you told me, your uptime's about 10%. And the manager is one of the more awkward experiences I've ever had in my life. The manager got like red in the face and actually started shaking. And he wanted to have the young engineer escort me from the building. I mean, it was really kind of upsetting. And so I said, well, don't get
the ultimate shoot the messenger, right?
Yeah. I said, don't get angry with me. Maybe I made a mistake. I said, why don't we measure the uptime for 2 weeks, and I'll come back in 2 weeks and a couple days, and we'll see what we can do. So the boss calmed down, and it just worked out perfectly. They had 5 process engineers, and what they agreed to do was every half hour they would go out, and in an Excel spreadsheet, they would have a cell. And if the line was running, they'd put a 1. And if the line wasn't running, they'd put a 0. And they'd do this for 2 weeks. And I would come back in, 2.5 weeks. And so they did that. And so the people doing it kind of kept it secret, and they didn't really reveal it until I got there. And I was wrong. It was not 10%. It was 9.7%. And so now the boss is more embarrassed than anything. And the thing, if you ask me, that I'm most passionate about is most engineers and most managers will be working on the head and pillow defect, voiding, whatever. They have no concept for how little time their line is running. And nobody seems to care about it. And it's shocking, because one of the comparisons I learned is, let's say the government called Mike Conrad up and said, Mike, we really need to get some more cash out in the world. And in Congress, somehow people think you're a really nice guy. We're going to give you a couple of money printing machines and the paper and ink, and you can print as many hundreds as you want. It's not going to be legal. And would you have those printers running 10% of the time? And so what I found is they actually did some things really well. Like they were a high mix, low volume, high mix line, where they had low volume runs and a lot of different runs. So they did a lot of setups, and they were pretty good in that they had whiteboards near each of the 2 lines where they'd say that they were getting the material for the next job that was coming, and even the job after that. So that was all good. But one of the things they didn't do is they didn't use feeder racks. So every time they changed a line, it took them 2.5 hours to get all of the new reels on the pick and place machines.
I love the reason they didn't use feeder racks. Yes. You have to share that.
This is all 100%
this is part of the consultant borrowing the watch, right? The answer was quite literally on the floor.
So I said to him, I know feeder racks are expensive, but I can show you that if you get, you spend the, whatever it is, $80,000 to get more feeder racks, so you can have the job running next. You have the reels already on the feeder racks, and you just run over and click them into the pick and place machine. And somebody said, we have feeder racks. And I said, why don't you use them? And I was standing right next to the pick and place machine. They said, can't you see the rug? The rug is torn and curled up, and the feeder racks stick on the rug. And what was almost sad to me is that someone can't realize that the benefit of saving 2.5 hours amount of time every time they do a changeover is just horrendous in the amount of money it will save you, the amount of productivity. So I said, well, let's get something like a box cutter and cut where the rug's frayed away. And then the manager was really embarrassed. He was kind of angry with the process engineers because I think they decided not to use the feeder racks and never told them. So we got that solved. And then I had been there for, quite a few days now watching things. And I said, well, lunch kills you. And they said, why? And I said, because you're down so long for lunch. And they said, well, what are you talking about? Lunch is only half an hour. And I said, it may only be half an hour, but your line is down for 90 minutes. And again, they got a little angry. And I said, well, don't say anything. Let's just watch what happens. Well, let's say lunchtime is at noon. Well, they wanted to make sure the line was shut down before lunch, so they shut it down at 11:45. And then lunch wasn't really a half an hour. It started at noon. It was really 40 minutes. And then by the time they got the line up and running again, it was essentially 1:15. So the line was down for an hour and a half.
Which is like 25% of their production day, if you think about it, right?
Yeah. Especially when you think about it, when you're only up 10% in an 8-hour day, you're only running 0.8 hours. I mean, just if you could do something about lunch, you'd double it. So I said, why don't you work out something where you can have the line running over lunch, like a skeleton crew or something? And they hummed and hawed and everything. They said, we can't do that. And I said, why not? I said, why can't you do that? And they said, well, because the operators are all friends and they want to eat lunch together. And I said, how much do they get paid per hour? And this was quite a while ago. It would be more now. And I remember it was $10 an hour. So this is a long enough time ago. That'd probably be $20 now, or $18. So I said, you can give everybody a $2 an hour raise, and you'll make more money if they can figure out a way to keep the line running over lunch. And this is again where the boss got angry with me. You just mean $2 raise just over lunchtime, don't you? And I said, no, a $2 an hour raise for a 40-hour week. And he said, that's impossible. I just can't believe this. So I showed him. I said, well, if we have the line running over lunch, that's 90 minutes you're not losing. It literally doubles your uptime, even if you don't use the feeder racks. And so I did some calculations. You're going to not only do you not need to buy another line, you probably will have some time when one of the lines won't be running. So they worked out a way that once a week, if you're an operator, you had to stay back for the lunch, and you had to run around hopping a bit for 40 minutes while the people were eating lunch. And then you only had to do that once a week, though, because let's say your day's Wednesday. On Thursday, it's your name's Mary, it's Charlie, and on Friday it's Pete, and on Monday it's Sally. So it's only one day a week, and you get a 20% raise. And the whole since this time, I have made almost an evangelism like effort to try to convince people the importance of uptime. And if you ask me, the most frustrating thing in our world is I can't get anybody to be excited about it. If I give a talk on productivity or a workshop, no one will attend. If I give a talk on how to minimize voiding or the head and pillow defect or graping, it'll be packed. But if I give one on productivity and I can show you how to essentially double your profits, nobody will come. And so,
I interviewed,
I just kind of shake my head.
A year or so ago, I interviewed a production manager from Matrix Group named Patrick Stimpert. And he is an automation and optimization and efficiency guru. He gives an example of, if you're left-handed, keep your pencil on the left-hand side of your desk, because the time it takes to, obviously that's a bit of an exaggeration, but that's kind of his mantra. He designed his production line in a figure 8, not a linear line, because he has goods in coming in one end of the building, goods out coming in another end of the building, and he designed all his bins and stock, shelves and stuff like that to be right near where they are. They pull them right where they use them, which required this kind of section, this 8-shaped production line. And his claim was that, we talked about U.S. competitiveness in assembly compared to offshore. And his claim was, it's not labor, it's automation. If we were highly automated and efficient, there's no country we could not compete against, because automation costs the same in China or Vietnam or Mexico as it does here, right? So, and if you can minimize the labor, I'm not talking about lights out factory. I think that's a little bit of a dream.
You don't have to minimize it that much.
You don't have to minimize it that much, but you just have to be extremely efficient. And automation, contrary to popular belief, is not the elimination of people. It still requires people. Someone has to feed the feeder, and set up the machines. But it's all about efficiency and optimization, and that we can compete with anybody if it's highly automated. I like to compare uptime on a pick and place machine to the airline industry. So Southwest Airlines, which is known to turn planes in 20 minutes at the gate, they realized, I heard a speech by their CEO a few years ago, and they were asked, why do you not charge for bags like every airline charges to check your bags? And, aren't you leaving some substantial revenue, on the ground? And they said, absolutely not. They did a study that if you were to charge for checked bags, what do people do? They drag their bags on the plane to the point where, after 2/3 of the people have boarded the plane, they have to gate check bags. That gate checking bags takes time, and they
don't charge for that. So
and they don't charge
right?
for that anyway.
Yeah.
It's not like it's revenue.
Interesting.
So the amount of money that they would make, the amount of revenue they would make checking bags, is much less than the amount of revenue they make by getting their plane in the air faster. Because they said, 100% of their airplanes are leased, not purchased, they're leased. So 24 hours a day, every minute of 24 hours a day, they're paying for that plane, but they're only getting revenue for that plane when the wheels are up. When the wheels are down, it costs them. When the wheels are up, they make money.
Yep.
So they need that plane to be wheels up more, just like this pick and place machine. 10% doesn't make them any money. They need something close to 30-35% to be highly efficient.
Yep.
Same thing. So if people can view reflow ovens and pick and place machines and all the various processes in an SMT assembly line, or an assembly line in general, like the airline industry does, at least the discount carriers, then they could realize that they're only making money when it's producing product for their customers. It's costing them money otherwise. And
that's so interesting because I didn't mention this. I developed some cost estimating software for electronics assembly, and when I give workshops on that, I show that if China pays China wages and we pay U.S. wages, and we're even like 5 or 10% more efficient, we're gonna kill them, because productivity is so important in your profitability. And I think that's what the same thing the Southwest is saying. That's so amazing that they figured that out and their competitors haven't.
Yeah, exactly. They're all still trying to nickel and dime the customer as opposed to...
And they count the nickels and dimes and makes it look like a lot, but then they don't count what they lose.
That's right.
In all that you just said, gate checking and all that kind of stuff.
That's right. Yeah, a typical airline has an hour at the gate, and Southwest is like 20 minutes, and obviously Southwest makes money. I also use Southwest to my team as an example of exceeding expectations. And I always remind my team, what airline consistently for decades has had the highest satisfaction level of any airline? And people will say, British Airways or Virgin or whatever. Like, no, it's Southwest. Southwest, they have terrible service. Like, no, they just don't overpromise. Your expectation when you get on a Southwest flight is that they will take you from A to B relatively on time. They probably won't kill you, and they might throw a peanut at you, right? I mean, that's it. You'll never complain you had a bad meal on Southwest because they don't serve meals on Southwest. So their expectation is low, and they deliver based on the expectation. So, if you set the expectation really high and then you deliver a crappy meal, people are going to complain that the Wi-Fi on the plane was too slow, as opposed to Southwest, which doesn't promise anything except they'll get you there.
Right.
So same thing. Changing subjects a little bit as we kind of wrap up. Recently, you invited me to kind of be an evaluator, a judge, so to speak, on some of your students' innovations course presentations. So you deal with engineering students, obviously, and this was an innovations course, which warmed my heart because I love to see some degree of business incorporated, infused into engineering, because a lot of these young graduating students will become entrepreneurs themselves. And if they're just too techie, if all they have is the tech mentality, they may not be able to exploit their knowledge and their gift of technical to the greatest extent they could. So I love that program of not just teaching the technical, but how to earn money, how to do seed rounds, how to prepare a business proposition, and things like that. So tell me a little bit more about that program. I think you took over that program from another professor who was a guest on my show.
Well, I took over the course.
The course, okay.
Yeah, so let me talk a bit about the program. A number of professors at Dartmouth noticed, I'm going to say it's probably 10 years ago or so, that there are a lot of PhD students and maybe even some other engineering students that have really good ideas in their research and have discovered some things that could be turned into a product, but not very many of them succeed. And so the professors decided to develop a PhD innovation program. So if you come to Dartmouth and are part of this program, you still have to do PhD type research. So you may be working on something in biomedical or something like that. You come up with a product or a process. You still have to do that and get a regular PhD. But you also can take some courses and get accreditation in the innovation program. And in a simplistic way, it helps you to learn how to develop a startup. And so the course I teach is about that, and that's a course you lectured in. And one of the founders of this is Professor Eric Fossum, who you've had on your podcast here.
The inventor of the CMOS image sensor, just to put a bow on him.
Yeah, and so he was just really overtapped with teaching courses and doing a lot of the wonderful things he does at the engineering school, helping the dean and everything. So I volunteered to teach the course. I've never really done a startup myself, but I've worked with a lot of people that have, and I felt that I could handle it. So it's really been a lot of fun because we've had a lot of speakers like you, and I mentioned this fellow Ron Adler, who I thought was amazing, one of the professors in the Tuck Business School at Dartmouth. So it's really been a lot of fun. And whenever you teach, you probably learn more than the students do.
For sure.
I think I knew 60% of the material before I went into teaching the course, but not 100%. And you always get a fresh perspective when you have speakers like you and some of the other speakers. So it was just really, really great. And I think the students probably appreciated the most having speakers like you, but people that have actually done it. And as you said earlier, talking about your mistakes, I think is as valuable as anything. So we think we're doing pretty well. A number of our students have started companies, and actually I had one of the gals in that just graduated probably 3-4 years ago, and she's already got a startup going, and she came in and talked about that. So the students really benefited a lot from that.
Yeah, I was impressed listening to their business proposals, and a couple points I was critical, but not because the proposals were bad, just because I wanted to provide some constructive criticism. Even if it was petty, it was. But
I guess we didn't mention to the viewers that part of the course is the students, have to not take tests, but they have to write some papers and whatever. But an important part of it is they break up into teams. I had about 20 some students, so they broke up into 5 teams, and each of them had a product that they were going to tell how they were going to develop a startup. And, they're going to have a business plan and, how much money they're going to need and all that. And so that's what Mike was one of the evaluators. And I had a handful of other people that were speakers in the class. One of the folks that we got to actually critique one of the presentations earlier in the course was a venture capital company. And of course, part of the course is how do you present to a venture capital group? So I've been working with some venture capital folks on another project. And I said, would you be willing to, we'll get one of our teams to present to you. And we just flipped the dice to determine which team it was going to be. And would you critique it just like you would a normal venture thing? And not only do students get a lot out of that, they've now made some contacts with these people. And as you know, an awful lot of life is having a good attitude and meeting a lot of people. You think about this, and this is why I'm so troubled about Zoom. Because so many people now are not going to have in-person meetings because Zoom works actually pretty well, let's be honest. Mm-hmm. But just think if the conference in Hawaii that you and I met at was a Zoom meeting, we would have never met each other. That's and right. I think both of us have had, a pretty rich amount of relations because of that chance meeting at breakfast. And I think it's kind of sad. And I'm a real now that COVID is hopefully way down in the concern list. I want to be back in the classroom with the students. I want to have as many in-person meetings as possible. I try to take students to lunches, as I think you've been to one or two of the lunches with me, and you've taken some students after the class for some discussions. You can't replace how important that is. And if we ever get too much replacing it with Zoom, I think it's really going to hurt us.
I totally agree. Zoom was a good substitute for no meetings at all. But unfortunately, it's Pandora's box, and it's hard to put back in. And a lot of bean counters at companies now will say, well, we survived for 2 years without travel. Let's keep going. Right.
But we save so many millions of dollars, right?
Right. And I think there's a time when that's appropriate. I'm on the board of the SMTA, and we have lots of meetings, and probably most of those are just as well virtual, because we have the ability to meet more often when we can do a virtual meeting.
Yep.
But the 3 or 4 other meetings that we do in person every year are vital, because you can just get the feedback. You can see the body language. There's nuances. There's the breakfast line where I look back and see you standing 20 minutes behind me, and it's
sure.
And so much. I was just at the SMTA Leadership Forum, and I was speaking on networking, and I actually told our story of how we met at breakfast, and then next thing you know, I'm speaking at Dartmouth, and we're doing shows together, and all this stuff, and that just kind of shows the power of networking, and one never knows, that 7 degrees of separation gets moved down to 1 or 2 when we're face to face, because there's just and that's subconscious networking. I didn't have a master plan. It wasn't a diabolical plan. I'm going to get Ron. I'm going to get in front of him in line. I'm going to exploit the situation.
Yeah, absolutely.
Imagine the power of a proactive, conscious networking. If actually people wanted to mix and mingle and for some gain, how much people can get ahead. But anyway, good job on the books. Any more books in the works?
Well, I've actually, maybe not a book, but so Patty and the Professor kind of went quiet, and every now and then I'd make another episode, but the people at iConnect ask if I might want to do something. So now I have one of Patty's students, Maggie Benson, and her fiance. Maggie's grandfather wanted to retire, and he had a small assembly company, a short drive from where Patty is now a professor. The professor helped her get a professorship at comically Ivy University, which is could be noticed as Dartmouth by some of the restaurants that I talk about the meeting in. But anyway, Maggie, I'm on episode 13. I do one a month, and it talks about her taking over her grandfather's company and putting lean principles in, and increasing uptime was a major thing. And so if you just type in Maggie Benson, Ron Lasky, iConnect, you should be able to get to the episodes. And again, it's a fun type thing. It's 60 to 70% of practical how you improve things, but 30 to 40% of Maggie getting engaged to her boyfriend, and the same time that her grandfather gives her the company, and some of the challenges they have with some of the people, and they buy another company, and the guy that sells it to them is a cranky guy that hates the workers and that kind of stuff. So, and I try to be in all of these at the end upbeat, with the belief that I think that for basically most people are trying to do the right thing. And if you work hard and you're kind to other people and everything, that the world will bless you back if you do that. And that's sort of the spirit in which I write these.
Pay it forward. Absolutely. So your book, The Printed Circuit Assembler's Guide to Solder Defects, is that published by iConnect, or is that Indium?
Yeah. It's I think you can get it on the Indium website, but it's iConnect actually helped Indium Corporation put it together. And there's a soft copy, but I think if you do a little web searching, they also sell it for a nominal price. I think like $10 if you want to get a hard copy.
Okay.
And if anybody wants a Patty and the Professor book, you can get the soft copy. But if you want a hard copy, I've got a few, or a hard copy of the defects book if you get one. If you tell me, I'll autograph either one for you.
Well, you heard it here first. First. If you want Dr. Ron to, AKA the Professor, even though he's technically not the professor in the book, I think his alter ego is certainly in there. If you want a signed copy of that, I will put you in touch with one.
I'd like to close with one other thing. You saw how passionate I am about productivity. So if any of the listeners out there have any questions about it, would like to talk to me about it, I'd be thrilled to try to help you, because it's so important and it seems to be neglected by quite a few folks.
Very good. Well, we'll have Dr. Ron's contact information in the show notes. Again, if you're on YouTube, click down there. It says show more. We'll have his contact information there. And if you're listening to this in the car, on the treadmill, wherever you listen to your podcasts, just look at the show notes on the podcast app that you're on, and you'll be able to see information on how to download the books and how to get in touch with Dr. Ron. Thank you so much for
Thank you.
being my guest
It's
today.
fun.
It's always good to
Love it.
see you.
Same
If
here.
not in person, this is a good second choice.
Yeah, sure.
And I'll look forward to talking to you again in probably the near future.
Sure. Thanks so much.
All right, take care. Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and the Innovations in Technology podcast, where we discuss innovative products within our industry. All three shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all three shows. Or go to MikeConrad.com. That's Conrad with a K. All three shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.